Hello everyone, my name is Cecily Watterson and I have the privilege of speaking to you guys today on the science of sunsets. To begin with, I would love to start talking about the movie The Lion King. This is a childhood classic for so many people. I believe it is due to the character development of Simba and just the cinematic masterpiece that it is, but also the gorgeous scenery that this movie instills. Partially the sunsets that are just magnificent. They draw us right in as watchers. And this leads us into the topic of sunsets. Why do people enjoy watching sunsets? What draws them to them? Do we even know why they exist? These questions are pretty much unanswered for the majority of people, and so I would like to take the time to explain them to you. I've done quite a bit of research. I've been in science classes for about 5 years trying to understand how particles work and move in the electromagnetic spectrum, and just how light appears in our eyes. And so I would love to share with you the science behind sunsets, especially with the electromagnetic spectrum, and then share the physiological response that our bodies have to this. Finally, we'll take a look at the most gorgeous places to watch the sunset around the world. Right here we have the very sciencey looking graph of the electromagnetic spectrum. As John O'Callaghan has written, the electromagnetic spectrum is a range of frequencies that corresponds to all different forms of electromagnetic radiation in the universe. It begins at the highest frequencies with the gamma rays over on this side, with the very short wavelengths, and then it goes to the lower frequencies with the very long wavelengths. This is the entirety of the electromagnetic spectrum, but here, for our purposes today, we will be looking right here in the middle at the visible light spectrum. This is the wavelengths that come through from the sun that we get to see and that give us the colors in the sunsets and the blue sky. Before we get into the science of sunsets, I need to explain to you how the sky appears blue. This is a good foundation for understanding everything. And so, as we see here, if I can pull this up, that we have the sunlight coming down from us, and we have the blue and the purple wavelengths that are the highest frequencies. They are disrupted by the air molecules the fastest, and so they spread out over the entirety of the atmosphere, and that's therefore what we see. John Rafferty says, the color of the sky depends largely upon the wavelengths of the incoming light, but air molecules, mostly nitrogen and oxygen, and dust particles also play an important role. The important role he's referring to is this disruption of the light waves coming in, and therefore we get the blue color of the sky. Moving on to the sunsets of the sky, we see here that when it's midday, the sunlight comes down and the blue and violet waves are disrupted because it comes straight down, shorter distance. Yet when the sunset happens, their light waves have to go a longer distance, meaning that, as National Geographic describes it, as the sun rises and sets, its light passes through much more of Earth's atmosphere, all of this part right here, before it reaches our eyes. Blue and violet light is scattered away. Only the long reddish wavelengths go the distance, thus making the sunset appear red. This is still due to the fact that the dust and air particles are there. John Rafferty says in one of his articles, these longer wavelengths strike dust and other particles near the horizon. So it's still due to the particles in the air that the sunset appears, and the bouncing off of the particles from the electromagnetic waves, but because of the farther distance, these waves then appear to be all the different colors instead of just blue to our eyes. So to quickly recap, what we've learned is the fact that the light and the color that we see in the sky is due to the electromagnetic waves coming from the sun. There are 3 factors that affect the sunset. One is the length of the wave of energy. The second is the distance that the energy has to travel before it reaches our eyes. And third, the dust and water particles that are in the sky reflect that light, and that's what we see. So now we get to ask the fun question of why do we even like to watch the sunset? Is it because you think it's beautiful? Yeah. Is it because it brings us together with community? Yeah. But also, there's a physiological response that we get when we watch the sunset. As Mia Chow explains, the production of melatonin, the hormone responsible for regulating sleep patterns, increases with the fading light, helping you feel more relaxed and ready for sleep. According to Mia, when we watch the sunset, it puts us in a state of relaxation. Our world is so busy at this point that any place that we can have that slows us down is very enjoyable. So where might we go to watch one of these gorgeous sunsets? You can go to your backyard for sure, but according to farandwide.com, travelandleisure.com, and roughguides.com, there are a couple places that you might want to know about to travel to next to watch the sunset. 1 just so happens to be Anchorage, Alaska. Number 2 on the list just happens to be Cape Town, South Africa. Number 3 comes in as Punta del Este, Uruguay. Number 4, right over my face, is Uluru, Australia. And number 5 is the romantic water city of Venice, Italy. Go to one of those places and you might just so watch the best sunset of your life. We've talked about a lot of information today, going from why sunsets happen to what the physiological response of those sunsets are and where you might find the best one you've ever seen. I have loved sharing this information with you, and if you keep on this journey with understanding sunsets better, you might just end up like Simba and his dad, watching the sunset on top of a rock, the most beautiful thing you've ever seen.